In this video, we're going to be building two exponential equations. This first one is very similar to one of the homework assignments. And we're supposed to use the first and second differences to determine whether or not the sequence, and there's our sequence, is linear, quadratic, or exponential. We're also told that the first term in the sequence corresponds to x equals 1, which is going to be important when we get to part B. Looking at these, I can tell just by looking at those numbers that finding the additive difference or subtractive difference between those numbers is not going to be that useful. Just by the nature of these, 8,000 to 800 to 80 to 8 to 0.8, I can tell that there's a multiplication difference, or maybe I should say a division difference, because what it looks like is going from one sequence to the next, we're dividing by 10. 8,000 divided by 10 is 800, divided by 10 is 80, and so on. However, we don't think about this in terms of division, we think about it in terms of multiplication. This is fine because every division problem can be rewritten as the multiplication of that reciprocal. So instead of saying, oh, this is divide by 10, I'm going to say this is multiplied by 1/10, which has the same effect. Or if you like decimals more than fractions, we can say this is multiplied by 0.1. And that pattern holds true. So since we have a multiplication pattern, times 0.1 times 0.1, we know that this sequence is exponential. Now let's write an equation for that in terms of x. So to write an equation, we already know that our form of our function is y equals some initial value a times b to the x power. The initial value is not necessarily this first number. This gets a little weird, especially with this problem. Normally, we will be given some initial value, but in this, we're told that the first term corresponds to x equals 1. That means what we really want for the first term is when x equals 0. We want the mysterious term right before this. So since we're getting to the following term by multiplying by 1/10, we could get to the previous term by multiplying by 10. That means this first term, when x equals 0, this mysterious first term would actually be 8,000 times 10, or 80,000. We have y equals 80,000 times some number multiplied in each time. And that number that's multiplied in each time is 0.1. Let's talk a little bit more about why we had to switch to 80,000 up from 8,000. When I put in an x value of 1 for our first term right there, that means this number here is going to get multiplied by 0.1. So if you put 80,000 times 0.1 raised to the first power, which represents our first term, what I have circled up there, it should equal, indeed, the first term in our sequence of 8,000. So our answer is 80,000 times 0.1 raised to the x power. There is our equation. Now we want to use this formula to find the next term in the sequence. We actually already know, or can easily figure out what that next term is, because we can just multiply 0.8 times 0.1. Our next number should be 0.08. Let's test our formula and see if that works out. So this is the sixth term that we're trying to find. So we would have y equals 80,000 times 0.1 raised to the 6th power. Plugging that into your calculator, we do indeed get 0.08. By the way, if you aren't sure how to do the exponent, you should look for the caret button on your calculator. That should raise it to that power. So our answer here is 0.08. We have our formula. In most of the other problems, we won't need to do this step backwards and find the previous initial value. Most of these problems we're given the initial value directly. Let's look at this problem. A population numbers 18,000 organisms initially, and then it decreases by 4.7% each year. Suppose that P represents the population, T is the number of years of growth. An exponential model for the population can be written in the form P equals A times B to the T power, where P equals, and then we need to answer this. So what we're given here is an initial value, and then B is going to be our growth factor, but we're given a percentage, we're given a growth rate. I'm going to think of B as 1 plus or minus the rate. So it's the R that's going to be, that represent that 4.7%. So it represents it as 0.047. Because we always write our percentages as decimals or fractions when we use them. Question is this going to be 1 plus 0.047 or 1 minus 0.047? Try to answer that yourself. Since it's a decrease, since it's a decay, it's going to be a minus, which means our B value is going to be 1 minus 0.047. B equals 0.953. So our function is our initial value of 18,000 times the B value of 0.953 raised to the T power. Thank you.